Hello and welcome to this presentation related to algebra revision. This presentation is not designed to teach you new topics, but to hopefully help you recap topics you have studied previously. The expectation is you will scan the presentation for the particular topic you wish to review and undertake the various exercises listed. Answers and solutions to all questions are stated. It should be noted that with some exercises there are several ways of solving the problem. I show you one particular solution here, but you may find other, possibly better solutions, and of course that's fine. Here's a brief overview of the presentation's contents. Initially I'm just going to mention the difference between properties and operators, and so highlight the conflation which unfortunately occurs within the actual presentation. This is essentially due to incorrect terminology on my part. I just want to highlight this issue before the actual presentation commences. I do realise that some students will not be particularly interested in this section, but for completeness I have added this section here. The algebraic revision commences with exercise 1A related to the laws and the rules of indices. Exercise 2A relates to the evaluation of expressions, includes bracket expansion and further use of indices. Exercise 3A, we simplify expressions involving bracket expansions. Exercise 4A relates to factorising expressions. Exercise 5A, we simplify algebraic expressions involving the use of BODMAS. Exercise 6A, we solve simple equations, that's equations with one unknown. Exercise 7A, we transpose or rearrange various formulae. Exercise 8A, we solve simultaneous equations with two unknowns using both the elimination and the substitution methods. And exercise 9A, we solve quadratic equations using both the factorisation method and also the formula. And here are the approximate start times related to the various exercises contained within the presentation to hopefully aid your ease of access through the presentation. But please note these are only approximate start times. Here's a brief recap of properties and operators, a topic area we reviewed in our previous presentation related to BODMAS. The property of a number or an algebraic symbol is usually stated as positive or negative. Within calculations, we have operators, such as typically a plus and a minus. So if we consider the illustration shown on the right-hand side here, within the upper calculation, this would be stated as negative 3 minus 2 multiplied by 5 plus 2 raised to the power of negative 2. With the lower calculation, we have a positive y raised to the power of negative 3. We're multiplying that by negative 5y squared minus negative 3 multiplied by y to the power of negative 1. However, sometimes the property of a number or algebraic symbol may be stated as plus or minus, in which case our operators now become add and subtract, or sometimes take away. If we now again consider our illustrations, for the upper calculation, we would now have minus 3 subtract 2 multiplied by 5, or sometimes termed 2 times 5, add 2 to the power of minus 2. Considering the lower calculation, we would have plus y to the minus 3 times by minus 5y squared, subtract minus 3y raised to the power of minus 1. So sometimes this different terminology can be used within calculations. What I just wanted to highlight to you here is that sometimes properties and operators can be conflated. So these are examples of conflation. So here I'm returning to the calculations and showing you how the terminology is conflated. If you notice in the upper line now, this states a minus 3 minus 2 times 5 add 2 to the power of negative 2. Can you see that the properties and the operators are conflated here? We've used minus initially to mean the property of the 3, but we're also using the term minus for the operation within the calculation. And considering the lower calculation, we have positive y raised to the minus 3. We're timesing that by minus 5. Then we're subtracting minus 3 raised to the negative 1. And again, we have conflation here because the property of the first term is defined as positive, but the properties of the second and third terms are defined as minus instead of negative. So the point I'm trying to make here is that conflation can occur within calculations, and unfortunately within the presentation that follows you will see that I do often conflate my properties and my operators. So I'm going to apologize for that. Obviously we should be very consistent within our terminology used in the calculations. So we really should be using properties denoted as positive and negative, and operators, for example, the plus and the minus. I'm very briefly referring to the quadratic formula that's used later in the presentation. It should state x is equal to negative b plus or minus the square root of b squared minus 4ac, or divided by 2a. Alternatively, the quadratic formula could be stated as x is equal to minus b add or subtract the square root of b squared subtract 4ac, or divided by 2a. Here again is an example of conflation by stating x is equal to minus b plus or minus the square root of b squared minus 4ac, or divided by 2a. We have conflation here because the first minus relates to the property, but the minus used here and here relates to operations. So again, unfortunately, you will see me conflate these terms within the presentation, but I'm just trying to make you aware of my misuse of the terminology. Again, I would encourage you to try and be consistent with your terminology for properties and for operators. The essence of the presentation is to recap algebraic techniques that will underpin later and more complex calculations, so I hope my conflation does not detract from your learning in this respect. If I had more time, I would re-record the entire presentation, but at the moment I'm trying to use my conflation to highlight awareness of the issue, and through this hopefully enhance your learning. So let's now commence the original presentation related to a recap of various algebraic techniques. And for your ease of reference, here again are the approximate start times of the various exercises within the presentation. Exercise 1A relates to indices. We're going to solve the problems shown here on this slide using the laws and the rules of indices. The answers are shown on the right hand side here in the brackets. I would encourage you to stop the presentation here and attempt this exercise before looking at the solutions on the following slides. Exercise 1A, we're asked to simplify the following expressions using the laws and the rules of indices. So part 1, we're given 7 multiplied by 7 to the 5 multiplied by 7 to the 9. Now don't forget that first term of 7 is actually 7 to the power of 1. We don't write the 1s, but they're there. So I've actually got there 7 to the 1 times 7 to the 5 times 7 to the 9. This is a first law of indices problem because the base is 7 here, are all the same and all the terms are multiplied together. So that follows the first law of x to the m times x to the n is simplified to x to the m plus n. So we're just simply going to add up the indices. So it's 7 to the power of 1 plus 5 plus 9, that's 7 to the 50. Part 2, we're given an expression here, m to the 5 times m to the 4 times m to the 6 times m to the 2, and the base here is m. So again, the first law of indices applies, so that becomes m to the 5 plus 4 plus 6 plus 2, that's m to the 17. Part 3, we're given 4 to the 8 divided by 4 to the 5. So that's a second law problem. We've got the same bases, the base of 4, top and bottom, divided. So that's a second law problem. So x to the m divided by x to the n, we're told is equal to x to the m take away n. So in this case, we'll have 4 to the power of 8 take away 5. That gives us 4 to the power of 3. Exercise 1a continued, part 4 here. This time we're given y cubed multiplied by y to the 4 multiplied by y to the 8. That's all divided by y to the 5 times y to the 6. There's several ways of tackling this, but what I'm going to do is simplify inside the brackets using the first law and then use the second law to divide the brackets. So looking at the expression inside the top bracket, first bracket I get y to the 3 plus 4 plus 8. That's the first law problem because the bases are all the same, it's all y. And in the second bracket I've got y to the 5 plus 6. That simplifies to y to the 15 divided by y to the 11. This is now a second law problem. We're dividing the same basis, so we subtract the indices, so that becomes y to the 15 take away 11, simplifies to y to the 4. Part 5, we've got 5 to the power of 3 all raised to the power of 3. Now that's a third law problem here. That's x to the m all raised to the power of n. So x to the m times n is the solution here. So that's simply going to be 5 to the power of 3 times 3, which will be 5 to the power of 9. Exercise 1a continued, part 6. We've got v to the power of 4 all raised to the power of 2. That's a third law problem of x to the m raised to the power n. So we're going to multiply indices here. So v to the power of 4 times 2 in this case, that becomes v to the power of 8. Part 7, we've got p squared multiplied by q to the 4 inside a bracket, and the bracket's raised to the power of 3. Now we look for simplification inside the bracket, but that's not possible here because they're different bases, the p and the q are different bases, so all we can do is apply the third law and raise each of the terms to the power of 3. So we'll end up with p to the power of 2 times 3 multiplied by q to the power of 4 times 3. Simplifies to p to the 6, q to the 12. Part 8, inside a bracket we've got a to the 7 divided by b to the 5, and it's all raised to the power of 6. Again, we can't simplify inside the bracket because the bases are different. So we're just going to use the third law here. So we get a to the 7 times 6 divided by b to the 5 times 6, which simplifies to a to the 42, b to the 30.
Just note for reference, there was an error on the previous slide, which has been corrected here. The expression should have stated a to the 42 divided by b to the 30, which could have been written also as a to the 42 multiplied by b to the negative 30. So please note the correction.
Exercise 1a continued, part 9, we're given 3 to the power of minus 1. And this is a negative index, it's item 5 in our list here. This is x to the power of negative n in this case. We've got 3 to the power of minus 1. So when you get a negative index, that really means it's reciprocal. It means it's 1 over x to the n. So in this case, the 3 to the power of minus 1 could be written as 1 upon 3 to the 1, or simply 1 upon 3. So a negative index means reciprocal, it means turn me upside down basically. Part 10, 5x to the minus 3. Just be careful with this. The negative 3 is only associated with the x. The 5 actually has a power 1 against it. We don't write the 1s, but there's a 1 there. So when we're looking at the reciprocal index here, we actually write 5 divided by x to the 3. So as the x to the minus 3 goes below the line, we change the sign of it, all based on this item 5 here in the laws of indices. So be careful there, the 5 does not go below the line, the 5 stays above the line, the 5 is to the power of 1. Exercise 1a, part 11, we're given 2a in brackets, all raised to the power of minus 4. So the first thing we could do here is to get rid of the negative. If we note from the laws of indices, the reciprocal law, that the x to the power of minus n is equal to 1 upon x to the positive n, then we could write the 2a all to the power of minus 4 as 1 divided by 2a to the power of positive 4. That's using this reciprocal index. That gets rid of the negative for us. Next, we've got a third law problem. We've got the 2a in the brackets all raised to the power of 4. And don't forget, there are 1s against the 2 and against the a here. So when we use the third law of indices, we've got the x to the m raised to the power n, gives us x to the m times n. So in this case, we'll get 1 times 4 is 4, so that's 2 to the power of 4, and a to the power of 4. Don't forget that 2 to the power of 4 is 2 times 2 times 2 times 2, so that's 16. So we end up with 1 divided by, in brackets, 16 multiplied by a to the power of 4. Part 12, we're given 1 divided by z to the power of minus 5. Now again, using a reciprocal index here on the right hand side, if we cross the line, we change the sign of the index. So we've got 1 divided by z to the minus 5. If we bring the z to the top line, we'll end up with z to the positive 5. Again, this idea of crossing the line, changing the sign. So 1 upon z to the minus 5 can be written as z to the 5. Exercise 1a continue. We've got some further questions here. We're asked to actually evaluate the following parts of exercise 1a without using a calculator. To help us solve these questions, table 1 might be useful, but it has several bases here raised to various powers, so the values in the table may be useful in helping us solve the problem shown on this slide. Again, we'll be using the laws of indices. If you want to have a attempt at these, I'd encourage you to stop the presentation now before reviewing the solutions on the following slides. These are quite difficult questions though. Exercise 1a continue, part 13. We're given 4 to the power of a half. Now, what we need to recognize is the half is actually a square root. If we think of it in this form here of x to the power of m over n, we're given the power of half, so our m is 1 and our n is 2. So if you look at the format here, this would be x to the 1, this would be a n of value 2, which would make it a square root. So try and remember that a power of a half is actually a square root. So in this case, we get the square root of 4, which is equal to 2. Part 14. We're asked to determine the value of 125 to the power of a third. Now from the table on the previous slide, we can find that 5 raised to the power of 3 is 125. 5 times 5 is 25, and 5 25s are 125. So what we get here is 5 to the power of 3, but it's all raised to the power of 1/3. Now that's going to be a third law problem, so we end up with 5 to the power of 3 times a third, and 3 times a third gives you 1, so we've got 5 to the power of 1, or simply 5. Part 15, we're asked to find the value of 81 to the power of a quarter. Again, from the table on the previous slide, you'll see an 81, which can be written as 3 to the power of 4. But that's raised to the power of a quarter. So again, the third law is used here. We get 3 to the power of 4 times a quarter. And again, 4 times a quarter is 1, so we've got 3 to the power of 1, or simply 3. Exercise 1a, part 16, we're asked to find the value of 8 to the power of 2 upon 3. What I'm going to do here is break this down. I'm going to actually write the 8 to the power of 2 upon 3 as 8 to the power of a third, all raised to the power of 2. I haven't affected the original question because using the third law of indices here, we know that when we've got a power raised to a power, we multiply the indice. So here we've got a third times 2, so it's still 2/3. But if I know that 8 to the power of a third is actually 2, in other words, the cube root of 8 is 2, and we get the cube root from the fractional rule of indices. If we've got x to the power of m over n, in this case we've got an m of 1 and an n of 3, then that will give us x to the power of 1, or third rooted, so it's a cube root here. So I get the cube root of 8 is actually 2, and 2 to the power of 2 is 4. Part 17, we're asked to calculate 16 to the power of minus 3 upon 4. So what we can do here again is break this down into 16 to the power of a quarter, and that's raised to the power of minus 3. Again, I've not affected the sum. I've still got 16 to the power of minus 3 upon 4, but I've broken it down. And what I've basically got in the bracket is a fourth root now of 16. And the fourth root of 16, you can look in our tables, would be 2. So I end up with 2 to the power of minus 3. Again, I can break that down if I want to. That could be 2 to the power of 3, or raised to the minus 1. So I've still got 2 to the power of minus 3, but I've broken it down because I know that 2 to the power of 3 is 8. I'm noting that 8 to the negative 1 is really 1 upon 8. We get this from the fifth rule of indices. X to the minus n can be written as 1 upon x to the n. So I can simply write 8 to the minus 1 as 1 over 8. It's actually 8 to the 1, but we don't put the 1s usually. Exercise 1A continued, part 18. We're asked to evaluate 3 divided by 2 in a bracket, and the bracket's all raised to the power of minus 3. Now don't forget the negative index, x to the minus n, is 1 upon x to the n, in other words reciprocal. So to get rid of the negative, we could simply reverse the 3 upon 2 and write 2 divided by 3, raised to the power of positive 3. So 3 upon 2 raised to the power of negative 3 is the same as 2 upon 3 raised to the power of positive 3. We can't simplify inside the bracket, so we're just going to use the third law here. So we get 2 to the power of 3 divided by 3 to the power of 3. Don't forget, there's actually a 1 here against the 2 and a 1 here against the 3. We never write the 1s, but they're there. So following the third law through, that would be 1 times 3. That's how we get the 3. 2 to the power of 3 is 8, and 3 to the power of 3 is 27. Part 19 here, we're asked to find the value of 9 to the power of 2.5. What I've done here is actually written that as 9 to the power of 5 upon 2. 5 divided by 2 is 2.5. But then I can write that as 9 to the power of a half to the power of 5. Because I still haven't affected the equation now. I've got 5 times a half is 5 upon 2. But I know that a half is a square root. And I can square root 9. So I get 3 to the power of 5. And then 3 times 3 times 3 times 3 times 3 would give me 243. Exercise 1A, part 20. We're asked to determine the value of 1 divided by the square root of 5, all raised to the power of minus 2. I could consider straight away using the 1 upon x to the n can be written as x to the minus n, in other words reciprocal. So instead of having 1 upon the square root of 5 to the minus 2, I could bring it to the top line and have square root of 5 to the 2, positive 2 there. Don't forget square root is a half, so that's actually 5 to the half, that's raised to 2. And from the third law, I can multiply the indices together, so I get 5 to the power of 2 times a half. 2 times a half is 1, so I simply get 5 to the 1 or 5. Exercise 2A, looking at simplifying algebraic expressions here. Again, I would encourage you to stop the presentation and see if you can attempt questions 1 to 5 there on this slide. The answers are given on the right hand side in the brackets. The solutions are shown on the following slides. Exercise 2A, part 1, we're asked to evaluate the expression 4 multiplied by a squared multiplied by b multiplied by c cubed. Take away 2 times a times c. We're given in the question that a is equal to minus 1, b is equal to 0.5, and c is equal to 2. All we're going to do is put those numbers into the expression and then evaluate it. Be careful of your BODMAS here there. So looking at the expression, I've got 4 multiplied by a squared, so that's minus 1 squared. That's multiplied by b, which is 0.5, multiplied by c, which is 2, and that's cubed. I take away then 2 multiplied by the a minus 1 multiplied by the c, which is 2. So using our BODMAS, first thing we're going to do is look at the indices here. So I will get 4 multiplied by minus 1 squared. Don't forget when you square a negative number, it's always positive, so it's 4 times the 1, multiplied by the 0.5, and 2 to the power of 3 would be 8. I add to that the last term, which is minus 2 times minus 1 times 2. Be careful of the directed numbers there. That is actually plus 4. Again, following the BODMAS, I must do the multiplication next. So I get 4 times 1 times 0.5 times 8. That gives me 16 plus my 4 equals to 20. Part 2. I'm asked to multiply 3x plus 2y by x minus y. Now I need to be careful here straight away. I really need the 3x plus 2y in its own bracket, because what I've got here really is a binomial bracket expansion. Putting the brackets together, I've got 3x plus 2y multiplied by x minus y. I don't know how you span your binomial brackets. I normally use what's called the crab-claw method. So I'm going to multiply the 3x by the x to get 3x squared, and then the 3x by the minus y to get the minus 3xy term. Then I multiply the plus 2y by the x to get plus 2xy, and then the plus 2y by the minus y to get the minus 2y squared. So that's my expansion on the next line. So 3x squared minus 3xy plus the 2xy minus the 2y squared. Collecting the like terms together, the two middle terms, I've got minus 3xy plus 2xy, so that gives me the minus xy term. So I get 3x squared minus xy minus 2y squared. Exercise 2a part 3, we're asked to simplify the a cubed b squared c to the 4, which is all divided by ab c to the minus 2. So write down two lines, that would be a cubed b squared c to the 4, all divided by the ab c to the minus 2. We're given a is equal to 3, b is 1 upon 8, and c is equal to 2. What I would suggest you do first of all is try and simplify these expressions algebraically, and we can see that the terms on the top and the bottom will actually cancel here. So we can end up with a squared, because we've got an a cubed on the top divided by an a to the 1 on the bottom. So for the second law, that will give us a to the 2 on the top. We've got a b squared on the top line and a b on the bottom, that's b to the 1 on the bottom. And again, the second law of indices will give us b on the top. And on the top line, I've got c to the 4, and on the bottom line, I've got c to the minus 2. Now be careful here, because what you've got basically is that c to the minus 2 on the bottom can become c to the 2 on the top. So I get c to the 4 times by c to the 2. Don't forget that's the reciprocal index. So in other words, I get a squared times by b times by c to the 6. Now I've simplified it algebraically, I just put my numbers in. A is 3, so that's 3 squared multiplied by the b, which is 1 upon 8, multiplied by the c, which is 2 to the power of 6. Evaluating that, you get 72. Part 4, we're asked to simplify x squared times y cubed plus x times y squared multiplied by, in brackets, xy to the power of minus 1. Now really what you've got there, because of the minus 1, is x squared y cubed plus xy squared all divided by xy, because a negative 1 means reciprocal. Actually means turn me upside down. I'm on the bottom line really. So you've got some cancelling here. You can see that the x squared in the first term on the top line cancel with an x on the bottom to give you x, and the y cubed on the first term on the top line cancel with the y on the bottom to give you y squared. The next term on the top line we've got xy squared, so the x divided by x will go to 1, so that will cancel, and the y squared divided by y will leave with plus y. What we can do now is factorise, because y is the highest common factor to both terms, so y could come outside the bracket, and inside the bracket I get xy plus 1. You can check that by expanding the bracket, and you'll get back to the xy squared plus y. Exercise 2a, part 5. This is a very complicated expression here. Don't worry if you have trouble with this. You've got x squared multiplied by the square root of y, and then that's multiplied by the square root of x times the y squared cube rooted, and that's multiplied by the x to the 5 times y cubed all to the power of minus a half. You don't need the brackets in the first two terms here. These brackets could be ignored, but you do need the brackets in the third term because it's to the power of negative a half. What you basically got here is x squared times y to the half, the square root is a y to the half, multiplied by x to the half, again the square root is a half, y to the 2 upon 3, again that's using the fractional index of the m upon n, so the m in this case is 2, y squared, and the root is 3, so that's 2 upon 3, and that's all divided by, on the bottom line, you've got x to the 5 upon 2 multiplied by y to the 3 upon 2.
Notice on the bottom line, because of the negative here, this negative means this bracket is actually on the bottom line, so that's why I've got on the bottom line. Tidying the top line, using the first law on the top line, you've got x squared times x to the half, so that becomes x to the 2.5 in decimals, and you've got y to the half multiplied by y to the 2 upon 3. Now using fractions there and a common denominator of 6, you'll find that comes to y to the 7 upon 6. Let you think that through, that's fractions you've got there. On the bottom line, we've got x to the 5 upon 2 multiplied by y to the 3 upon 2. What I've done on the next line is actually bring the bottom line to the top. So I've actually written is x to 2.5 times y to the 7.6, and then multiplied by x to the minus 2.5, and then multiplied by y to the minus 3 upon 2. Now just looking at the x's, you can see they cancel because you've got x to the 2.5 here and x to the minus 2.5 here. So the first law of indices means they cancel. And to bring the y's together, you've got y to the 7 upon 6 multiplied by y to the minus 3 upon 2. That's a first law problem, but again you've got fractions there to deal with. So I just showed you down here in this note how we deal with the fractions. You've got y to the 7 upon 6 multiplied by y. Now the minus 3 upon 2 can be written as minus 9 upon 6. I'm using the 6 as the denominator here so I can add the terms together. So minus 3 upon 2, if I factor top and bottom by 3, I get minus 9 upon 6. And now I can simply add those terms together using the first law of indices. So y to the 7 upon 6 times y to the minus 9 upon 6 can cancel down to y to the minus 2 upon 6. So 7 take away 9 gives you minus 2 upon 6. That cancels to y to the minus 1 upon 3. Cancel top and bottom by 2, and don't forget that's basically a cube root term, so that's y to the third all raised to the power of minus 1. So I've really got this term here basically, and don't forget the negative means 1 upon the y to the third, or 1 upon the cube root of y. Again, very complicated expression, don't worry too much if you can't follow that one, but interesting little simplification. Exercise 3a here, further terms to simplify. Again, I would encourage you to stop the presentation and have an attempt at these first of all, before looking at the solutions on the following slide. The answers are again in the brackets on the right hand side. Exercise 3a, part 1. We're asked to simplify a squared, take away, in brackets 2a minus the ab, and then take away a multiplied by 3b plus a. So we're going to expand the brackets first of all, so we get a squared take away 2a plus ab. Notice the sign change there for the minus times the minus. And then we get minus 3ab and then minus a squared. Just be careful of the sign changes we've got there. When you have a negative outside the bracket, it changes the sign of everything inside the bracket. We can notice that straight away the a squared cancel with the negative a squared here, so those terms disappear. And then bringing the other terms together, we get minus 2a and then minus 2ab. That comes from the plus 1ab here. Take away the 3ab here, gives you minus 2ab. We can factorise on minus 2a, it's the highest common factor for the terms. So the minus 2a goes outside the bracket, and inside the bracket we get 1 plus the b. You expand the bracket, you get back to the previous line. Exercise 3a part 2, a more complicated expression to simplify. There are lots of different brackets here, different style of brackets. I've only used those to show that we've got nested brackets here, make it easier to see that there are 3 nested brackets. So we're given the expression of 2a, take away, open first bracket, 3, open second bracket, 2, multiply open third bracket, of 4a minus b, close bracket, take away the 5, then a plus 2b in the next bracket, close the bracket, plus 4a, close the final bracket. So we've got nested brackets here. First thing we're going to do is expand the curved brackets. So we get 2a take away 3, and then we get 8a, that's 2 times the 4a, take away 2b, 2 times the minus b, and then we get take away 5a from the next bracket, and then take away 10b. Be careful there, minus 5 times the plus 2b is minus 10b, and then close that bracket, and then plus 4a, close the final bracket. If we collect like terms together inside the square brackets,
we can simplify slightly. So we get 2a take away, open bracket 3, and then inside the square bracket we've got an 8a take away a 5a, so that gives me 3a, and we've got a minus 2b minus 10b, that gives minus 12b, plus the 4a, and then close our big bracket. If we now expand the square brackets, we'll get 2a take away, we get 3 times 3a is 9a, and we get 3 times the minus 12b is minus 36b, plus the 4a, and then close our end bracket there. Again, we can collect like terms inside the bracket, so we get 2a take away, we've got a 9a plus a 4a, so that's 13a, and then take away the 36b. If we now expand the final bracket, we get 2a take away 13a plus 36b. Just be careful there of the sign change. Collecting the like terms together, we get 2a minus 13a, so that's minus 11a plus the 36b. All I've done on the last line is interchange the values, because if we have a positive and negative term, we normally put the positive first. That's convention. So 36b take away 11a is the correct answer. Exercise 4a, given 3 parts of this question, we're asked to factorise here. And again, I would encourage you to attempt these questions before moving on to the solutions on the following slide. Again, the answers are shown in the brackets on the right. Exercise 4a, part 1, we're asked to factorise the xy take away 3xz. So we look for the highest common factor. In this case, it will be x. So x comes outside our bracket, and inside the bracket we will get y take away 3z. If you expand the bracket, you'll get back to the previous line. Part 2, we're asked to factorise 4a squared plus 16ab cubed. Again, look for the highest common factor. As far as the numbers are concerned, we've got 4 in the first term, and 4 goes into 16 4 times, so 4 is the highest common numerical value. And looking at the algebra, we've got a squared in the first term, a in the second term, so a is the highest common factor, so 4a outside. B is not common because it's not into both terms, so just the 4a is common. Taking that outside the bracket, inside the bracket we'll get a take away 4 times b cubed. Again, you can check it by expanding the bracket. Part 3, we're asked to factorise 3a squared b take away 6ab squared plus 15ab. So again, look at the numerical values. You've got a 3 in the first term, the minus 6 in the second, and the plus 15. They're all divisible by 3. So 3 is the highest common numerical value. Looking at the a, we've got an a squared in the first term, an a in the second, an a in the third. So a is the highest common factor. And looking at the b, we've got b in the first term, b squared in the second, b in the third. So b is the highest common factor. So 3ab is the highest common factor for all the terms. Inside the bracket, we'll get an a minus 2b and a plus 5. Again, you can check that by expanding the brackets. Exercise 5a, we're asked to simplify the following expressions. Again, I would encourage you to stop the presentation here and have an attempt at these questions before reviewing the solutions on the following slides. Answers are in the square brackets. So exercise 5a, part 1, we're asked to simplify 3c plus 2c times 4c plus c divided by 5c minus 8c. Now be careful of your BODMAS here. Don't forget the precedent is with brackets first, but there are no brackets. With operations next, assign squares, that kind of function, they're not there. And then next it's division and multiplication. So I've done the division first before I do the multiplication. So looking at the division here, we will get 3c plus 2c times 4c plus then c divided by 5c. Think of that as being 1c. If I put a 1, it might help you follow the pattern through there. 1c divided by 5c. So the c's cancel to leave you with 1 upon 5, and then take away the 8c. If I look at the multiplication next, I've got the 2c times the 4c, so I'll get 3c plus 2 times 4 is 8, c times c is c squared, plus the 1 upon 5 minus the 8c. Looking at the addition next, I've got the 3c take away the 8c, so that will give me minus 5c, and I've got the 8c squared plus the 1 upon 5th from the previous line. All I can do to factor here is on the terms with the c in them. I've got the 8c squared minus the 5c, so c is common to those terms, so I could write c outside and then 8c minus 5 inside, and the fifth just remains as it is on its own. That seems to be the best I can do to simplify that expression. Part 2, got to simplify the following. So in brackets 2a minus 3, and that's all divided by the 4a, plus the 5 times the 6, take away the 3a. I'll undertake division first of all, do one step at a time here. So the 2a minus 3 divided by 4a. Now I'm going to take each term in the bracket and divide it by 4a. So think this through. 2a divided by 4a gives you a half. The a's cancel, and 2 upon 4 cancels to 1 upon 2. Then the minus 3 divided by 4a stays as minus 3 divided by 4. I can't simplify that term. Got my plus 5 times 6 minus my 3a. If I look at the multiplication part of the expression next, I get my 1 upon 2 minus my 3 upon 4a. Then I get plus 30 for the 5 times 6, take away the 3a. Finally, I look at the addition. The only thing I can add up here are the numerical values. Nothing else I can add up because it's not like terms. So all I can do is add the 30 to a half to get 30 and a half, or 30.5. Take away the 3 divided by 4a, take away the 3a. There's nothing I can do really to simplify that any further. Exercise 6a relates to simple equations. Don't forget that a simple equation has one unknown in the equation. Got 3 questions to attempt here. Again, I would encourage you to have a go at these before looking at the solutions on the following slides. Answers are given in the square brackets. So exercise 6a, part 1, we're asked to solve 4 minus 3x is equal to 2x minus 11. Now don't forget the essence of the solution is to get all the x's onto one side, all the numerical values on the other side. So the first thing I'm going to do is add 3x to both sides. So I will get 4 on the left hand side, and then 2x plus 3x is 5x, and then take away the 11. Next I'm going to add 11 to both sides, so I will get 11 plus 4 gives me 15 on the left hand side is equal to 5x on the right hand side. Now I've got all my x terms onto one side and my numerical values on the other. I simply now divide throughout by 5 and I find x equal to 3. You can always check the answers by putting the value of x back into the original equation and seeing if both sides balance. Part 2, we're asked to solve the equation 4, open bracket, 2a minus 3, close the bracket, take away 2, open bracket, a minus 4, which is equal to 3, open bracket, a minus 3, close the bracket, take away 1. So the first thing I'm going to do is expand the brackets. So 4 times 2a is 8a, and 4 times minus 3 is minus 12. Minus 2 times a is minus 2a, and minus 2 times minus 4 is plus 8. On the other side, right hand side, that gives me 3 times a, 3a, and then 3 times the minus 3 is minus 9, take away the 1. If I bring my like terms together, on the left hand side 8a take away 2a is 6a, and minus 12 plus 8 is minus 4. On the right hand side I get 3a, and then minus 9 minus 1 is minus 10. If I now subtract 3a from both sides, I will get 6a take away 3a. On the left hand side gives me 3a, so 3a minus 4 is equal to minus 10 on the right hand side. And if I add 4 to both sides, I will get 3a is equal to minus 6. That's a minus 10 plus 4. Dividing both sides by 3, a is equal to minus 2. Exercise 6a, part 3. We're given here in brackets t to the power of a half plus 3, and that bracket is multiplied by t to the power of minus half. That's equal to 2. We've got to solve this for t. So first thing I'm going to do is expand the brackets by t to the minus a half, and using indices we can see straight away we get t to the naught, because t to the half multiplied by t to the minus half, that's the first law of indices problem. We add the indices together, so a half take away half is 0, and don't forget anything to the power of 0 is 1. Expanding the next term I get 3 times t to the minus a half, so that's plus 3 t to the minus half, still equal to 2 on the right hand side. So as I said, t to the naught is 1, so I get 1 plus 3t to the minus half is equal to 2. If I subtract 1 from both sides, I get now 3 times t to the minus 1 half is equal to 1. It's taking 1 from both sides. If I divide throughout by 3, I get t to the minus half is equal to 1 upon 3, a third. Now don't forget the negative index means reciprocal, so I could actually turn the left hand and right hand side upside down, so I get t to the half on the left hand side if I turn the upside down the left hand side, and if I turn the right hand side upside down I get 3 upon 1, or simply 3. Now don't forget the half is actually a square root here, so what I need to do now is square both sides to get rid of the half on the left hand side. So squaring the left hand side I will get t, and then squaring the right hand side, 3 squared is 9. Again, very complicated solution. I suggest you have a little look at that and try and see if you can follow each of the lines as we go through a solution there. Exercise 7a relates to transposition of equations. We're given 8 questions here on the left hand side to solve. You've got to transpose for the variable in the bracket, and the answers are given on the right hand side here for the final transpose form. I would encourage you to stop this presentation for a few moments and have an attempt at these before reviewing these solutions on the following slide. Exercise 7a, transposition of equations. So part 1. We're asked to make t the variable given the formula v is equal to u plus at. Now to undertake my transpositions I'm going to use inverse operations. So I want to get rid of the u first of all here. Now the u is actually a positive term because there's a positive in front of the u here, which we don't write, but that's positive. So to get rid of the u from the right hand side, I will take u from both sides. So v minus u is equal to at. Now I want to get rid of the a to leave myself with t. At the moment the a is multiplying by the t, so the inverse operation is to divide. So I'm going to divide both sides by the a. And I'm dividing throughout by a. All terms get divided by a. So that gives me t is equal to v minus u in brackets, all divided by a. Part 2, I've got to make u the subject given the formula v squared equals to u squared plus 2as. So again I've got to get the u squared on its own. So I want to get rid of the 2as first of all, so I'm going to take 2as from both sides of the equation first of all. So v squared minus 2as is equal to u squared. I've got u squared on its own, but I want u. So what's the inverse operation to squared? It's square root. So I'm going to square root both sides of the equation. So u squared square rooted gives me u, and I must square root the other side of the equation. I get square root of v squared minus 2as. Exercise 7a, part 3, we're asked to make k the subject of the formula m is equal to u minus kt. Now the first thing I'm going to do here is actually add the kt to both sides of the equation just to make it positive, because I need the variable to be positive. So m plus kt is equal to u. To get rid of the m, I've got to take it away. Don't forget that the m is positive. There's a positive in front of the m, which we don't write. So to get rid of it, I must take it away from both sides. So I end up with kt is equal to u, take away m. And I want to make k the subject. At the moment, the k is multiplying by the t. So to get rid of the t, I have to divide both sides by t. So k is equal to u minus m in brackets and divided by the t. Part 4, I've got to make e the subject given the formula v is equal to the square root of, in brackets, 2e divided by m. So because the e is inside the square root, inside the bracket there, I'm going to have to get rid of the square root first of all. So the inverse operation to square root is square. So the first thing I'm going to do is square both sides. So v squared is equal to 2e divided by m. I want to make m the subject, so I'm going to multiply throughout by m, in this case to get m on the top line. So multiplying both sides by m, on the left hand side I get m times v squared, and on the right hand side I get 2e, because I've multiplied through by m, so the m on the top and bottom cancel on the right hand side. So finally, to find e, I'm simply going to divide throughout by 2. So e is equal to a half times mv squared. You could also write that as e is equal to mv squared divided by 2. Both are the correct solutions. Exercise 7a continued, part 5. We're asked to make y the subject of the equation x equals to b plus a times y squared. The first thing I'm going to do is get rid of the b on the right hand side. So I'm going to take b from both sides of the equation. So x minus b is equal to ay squared. I need to now get rid of the a. The a is multiplying the y squared, so I'm going to divide both sides by the a. So x minus b in a bracket, you must have a bracket there, divided by a is equal to y squared. I want y though, not y squared, so we need to square root both sides. So y is equal to square root of the x minus b divided by a, all in the brackets there.
careful of the bracketing format. You need the brackets there. The x minus b must be in a bracket, and then the x minus b divided by a is in another bracket because it's all square rooted. Part 6. We're asked to make u1 the subject given the formula f times t is equal to m, and in brackets v1 minus u1. So because the u1 I'm looking for is inside the bracket, I need to get rid of the m. I could expand the brackets is one way of doing it, but I'm just going to simply divide by the m. That will free the bracket. So the m is multiplying the bracket on the right hand side, so inverse operation is to divide. So f times t divided by m on the left hand side is equal to v1 minus v2 on the right hand side. On the next line I'm going to add u1 to both sides just to make it positive. So u1 plus the f times t divided by m is equal to v1, and then to get u1 as a subject I simply take away the f times t divided by m. So u1 is equal to v1 take away in brackets f times t divided by m. Exercise 7a, continue part 7. We're asked to make u the subject of the formula 1 upon u plus 1 upon v is equal to 1 upon f. Now if your fractions are quite proficient, you might want to solve this using fractions. If not, then the method I'm showing you here might be preferable. With this method shown, we're going to multiply throughout by u. So every term now gets multiplied by u. So the first term is u divided by u would be 1. There's plus then u divided by v is equal to u divided by f. So every term is multiplied by u. Next I'm going to multiply throughout by v. So every term is multiplied by v. So 1 times v is v, and then the u divided by v times by v will cancel to give you plus the u. And on the right hand side you'll get uv divided by f. I'm now going to subtract u from both sides of the equation because I've got to make u the subject and it's on both sides of the equations, u on the left and u on the right. I need to bring them onto one side of the equation. So I'm going to take u from both sides. So I'm left with v is equal to uv divided by f take away u. I'm now going to factorise on the u because it's common to both terms on the right hand side. So I get v is equal to u, and in brackets I get v divided by f take away 1. So I factorise both terms on the u. I now simply divide both sides by the vf minus 1 in the bracket, so I get u is equal to v divided by f minus 1. That's a solution, but if you wanted to, you could simplify slightly further by multiplying every term top and bottom by f. And if you do that on the right hand side, you get u is equal to v times f divided by, on the bottom line, v take away f. So think that through. Every term gets multiplied by f. So you've got v on the top times by f. On the bottom line you've got the v divided by f, but that's now times by f. So the f's cancel, give you v, and you've got the 1 times by f. So that gives you the minus 1 in this case. Just think that through for yourself. A very difficult problem, so don't worry too much if you can't solve that kind of question, because we're not going to meet that too often. Exercise 7a continued. This is part 8. In this question we're asked to make t the subject given the formula z is equal to xt squared, all divided by the u minus t squared in the bracket. This is again quite a complicated problem because on the right hand side you've got t squared in the top line in the numerator and t squared in the bottom line denominator. What you need to do here is collate the t squares together, and then eventually you'll be able to square root the solution. So the first step to do is to multiply both sides by the u minus t squared in the bracket. So that's what's done here. The z times the u minus t squared in the bracket is equal to xt squared. What you do then is expand the brackets, then bring all the t squared terms onto one side, factorise on the t squared, and then make the t squared the subject from where you can square root both sides to find t. So quite a complicated solution. I'll let you wander through the solution at your leisure and see if you can follow the steps. But this is the top end of the transpositions we'll be involved with in this course. Exercise 8a relates to the solution of simultaneous equations. There are 2 parts to exercise 8a. I would encourage you to attempt simultaneous equations. The answers are given on the right hand side of the bracket here. Don't forget there are 2 unknowns in x and y to solve for. Solutions are shown on the following slides. Exercise 8a, simultaneous equations. Part 1 we're going to solve with the elimination process. We're given in the question two equations. 7x minus 2y is equal to 26, and also 6x plus 5y is equal to 29. And with the elimination process, what we've got to do is have all the x's and y terms onto one side of the equation and the constants on the other. And that's the way the equations have been given to us in this particular question, but they're already in the right format. So using the elimination method here. Writing the equations from the question, we get 7x minus 2y is equal to 26. I've called that equation 1. And 6x plus 5y is equal to 29. I've called that equation 2. Now with the elimination method, what we've got to try and do is make the coefficients, that's the numbers, associated with either the x or the y to be the same. So in this particular case, I'm going to factor up the y coefficients to make them the same, and then I'm going to add the equations to eliminate the y terms. So to make the coefficients of y the same, I need to multiply equation 1 by 5 and equation 2 by 2. So what we get here then, taking equation 1 and multiplying by 5, 5 times 7x is 35x, 5 times minus 2y is minus 10y, and the 5 times 26 is 130 on the right hand side. Taking equation 2 and multiplying throughout by 2, 6x times 2 is 12x, 5y times 2 is plus 10y, and 29 times 2 is 58. So what we've done here is make the magnitudes of the coefficient of the y terms to be both 10, but one is a positive 10 and one is a negative 10. So in this particular case, we'll have to add the equations to eliminate the y terms. So think of us now as adding the two equations together. So 35x plus 12x gives me 47x, minus 10y plus the plus 10y, that's 0y, and on the right hand side 130 plus 58 is 188. Rearranging the equation to find x, 188 divided by 47 gives us a value of 4, so x is equal to 4. So to find the value of y, we simply back substitute the value of x into any of the equations. I've chosen equation 1 here. So using equation 1, 7 times x, this time it's 7 times 4, take away 2y is equal to 26. So that's 28 take away 2y is equal to 26. If I then take 28 from both sides, I get minus 2y is equal to minus 2. And if I divide throughout by the minus 2, y is equal to 1. So the solutions for these simultaneous equations are x is equal to 4 and y is equal to 1. And you can check those answers by putting them back into the original equation and see if the left-hand side equals the right-hand side. Exercise 8a here. Part 1, we're given two equations to solve. We've got two unknowns here, so we need two equations to solve it. The unknowns are the x and the y. I'm going to use the substitution method to solve in this particular case. So I've labelled the equation 7x minus 2y is equal to 26 as equation 1, and the 6x plus the 5y is equal to 29 as equation 2. So the first step using substitution is to obtain one of the equations as an expression in terms of either x or y. So in this particular case, I've chosen equation 1 and I've decided to rearrange that in terms of x. So given 7x minus 2y is equal to 26 for equation 1, to get x on its own I have to add 2y to both sides and divide throughout by 7. So I get x is equal to 26 plus 2y all divided by 7. And that's equation 1a. Exercise 8a, part 1 continued. What we're going to do now is substitute equation 1a into equation 2. And I've repeated these equations from the previous slides for convenience. So here's equation 1a and here's equation 2. So what we're going to do is put this value of x, the 26 plus 2y divided by 7, for the x in equation 2. And that's what's happened here. This here is the x term from equation 1a. What we've done by doing this is actually remove the x term from the equation just to leave us with y terms. So we've made the simultaneous equation, if you like, into a simple equation where we can now rearrange it to solve for the value of y. So what I've done on the next line is to get rid of the 7 in the denominator. I've multiplied throughout by 7, so every term got multiplied by 7. So I get 6 times in brackets 26 plus 2y, the 7's cancelled because I've multiplied by 7, but I've got to multiply the other terms by 7, so I get plus 35y, so that's 5 times 7, and that's equal to 203, which is 29 times 7 on the right hand side. All I do now is expand my brackets, collect my terms together, and rearrange to find y. So I'll let you wander through those few lines here, but you should find that y in this case is equal to 1. To find the value of x, what we do is we back substitute into equation 1a. So we've got the value of y now, and we're simply going to put that into equation 1a here to find the value of x. So x is equal to the 26 plus 2 times the y, and the y we know is 1. Evaluating that, you get x equal to 4. So our solutions in this case is x equal to 4 and y is equal to 1. And we can always check those answers by putting them back into the original equations and see if the equations balance. Exercise 8a, simultaneous equations. Part 2, going to solve with elimination. We're given two equations. X divided by 8 is equal to y minus 2.5, and also 11 plus y divided by 3 is equal to 3x. With the elimination method, what we have to do is get all the x's and the y terms onto one side of the equation and all the constants on the other. So that's what I'm going to do first of all. So using the elimination process, let's get all the x's and y's over to the left hand side. So considering the first equation, I've got x divided by 8, I've written that as 1x divided by 8 here. Take away the 1y, I've taken the y from the right hand side to the left hand side, is equal to minus 2.5. I've called that equation 1. Looking at the second equation, I've got 3x on the right hand side, so what I'm going to do is take basically y divided by 3 from both sides, and I've just rewritten the equation the other way round here. So 3x take away y divided by 3 is equal to 11. So just rearrange the equation again to get the x's and y's on one side and the constants on the other. I've called that equation 2. I suggest you just take a moment to make sure you understand the algebraic rearrangement there. With the elimination method, what we've got to do is get the coefficients, that's the numbers, associated with either the x or the y terms to be the same. So in this particular question, from what I can see, the easiest way of doing that is to multiply equation 2 by 3. That way we will get the coefficients of the y terms to be the same. In other words, both minus 1. So I'm going to leave equation 1 as is, basically just multiplying that by 1. So I'll write over here 0.125x, that's basically 1 divided by 8 in decimal. Take away the 1y is equal to minus 2.5. So just reformatted the equation, but it's basically the same equation. Looking at the second equation, I'm multiplying that by 3 now. So multiplying throughout by 3, 3x times 3 is 9x. The minus y upon 3 times by 3 will be minus 1y, or just minus y. And then on the right hand side, 11 times 3 will give me 33. Now I've got the coefficients of the y terms to be the same, it's both minus 1. If it helps in your understanding, just think of the minus 1 being here in the equations. So what we do now is try and eliminate the y terms, and to do that we need to subtract the equation. In this particular case we're subtracting the equations, so we're going to take away the equation, so take away sign here. So now we've got 0.125x take away 9x, so that will give me minus 8.875x. The minus 1y take away the minus 1y, that's basically minus 1y plus 1y, so that's 0y. And on the right hand side, minus 2.5 minus the 33 gives us the minus 35.5. Notice the negatives cancel on either side there, and rearranging we get x is equal to 35.5 divided by 8.875, which gives us a value of 4. So x is 4. To find the value of y, we now simply back substitute the value of x into any of the above equations, 1 or 2. I've chosen 1 here. So we're simply going to put the value of x into the equation. So instead of having x divided by 8, we've now got 4 divided by 8. Take away the y is equal to minus 2.5. Now just simply rearrange the equation. On the next line, I've just simplified the 4 divided by 8 is 0.5. Take away y is equal to minus 2.5. And then if I take 0.5 from both sides, I end up with minus y is equal to minus 3. Minus is cancelled there, so y is equal to 3.
So the answer to the solution of these simultaneous equations is that x is equal to 4 and y is equal to 3. And again, you can check those answers by putting the values back into the original equation and seeing that the equations balance. Exercise 8a, part 2. We're going to use substitution to solve these simultaneous equations. So from the question, we've got x divided by a is equal to y minus 2.5, called that equation 1. And we've got 11 plus y divided by 3 is equal to 3x, I've called that equation 2. What I'm going to do here is rearrange equation 1 to make x a subject, and I'm going to substitute it into equation 2. So taking equation 1 from x divided by a is equal to y minus 2.5, that was given in the question. To get x as a subject, I simply multiply throughout by 8. So on the left hand side I get x is equal to 8y minus 20, multiplying throughout by 8. Call that equation 1a. Exercise 8, part 2 continued. So what I'm going to do now is substitute equation 1a into equation 2, and I've just repeated the equations here for convenience, 1a and 2. So looking at equation 2, I'm going to put the value of x into the right hand side. That's what I've done here. So I've got 11 plus y divided by 3 is equal to 3 times, this is the value of x now, of 8y minus 20 from equation 1a. I've removed the x from the equation, so now I just have to solve for y like a simple equation by rearranging. So on the next line I've got 11 plus y divided by 3 is equal to, expanding the bracket, 3 times 8 is 24y minus is 3 times 20 is 60. What I've done on the next line is multiply throughout by 3 to get rid of the denominator on the left hand side. So 11 times 3 is 33 plus the y, because when I multiply the y upon 3 by 3 I get y. On the right hand side, 24y times 3 is 72y, and minus 60 times 3 is minus 180. On the next line, I've added to both sides the 180 to get 213 on the left hand side, and I've taken 1y from both sides to get 71y on the right hand side. Divided throughout by 71, y is equal to 3. To find the value of x, we back substitute into equation 1a, so x is equal to 8 times y, well y is 3 above, take away 20, evaluating the equation to get x equal to 4. So we know x is equal to 4 and y is equal to 3. Exercise 9a is solution of quadratic equations. I would encourage you to attempt these questions before reviewing the solutions on the following slides. Questions 1 and 2 require solutions using factorisation, and questions 3 and 4 require solutions using the quadratic formula. Quadratic formula is x is equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. Answers are given in the brackets on the right hand side. Exercise 9a, part 1. We're asked to factorise the equation 3x squared minus 11x minus 4 is equal to 0. That's of the form ax squared plus bx plus c is equal to 0, the form of a quadratic equation. I'm going to use a little tabular method to help me factorise this. The left-hand column here relates to factors of the ax squared term, the 3x squared term in this case. And factors of 3x squared are 3x and 1x. That's the only factors we could have if we're using whole numbers. The right-hand columns relate to factors of the c term, in this case the minus 4. So two numbers that multiply together to give you minus 4 are 1 and minus 4. With this method we cross-multiply to try and find the middle term. So in this case we've got 3x multiplied by minus 4 is minus 12x, and we've got 1x times 1, so that's plus 1x. Adding them up, minus 12x plus 1x is minus 11x. Is that the middle term? Yes, it is in this case. So immediately we've got our factors. We read horizontally for the factors. The factors are 3x plus 1, written in the bracket, multiplied by x minus 4 in the bracket. If we expand the bracket, we get back to the original equation, and you can check that if you want to. What I have shown in the table in the other right hand columns are other possible factors of the minus 4. So having the minus 1 and the 4 in this order would have been factors of minus 4, but if you cross multiply them, you'll find you do not get minus 11. And also having 2 and minus 2, or minus 2 and plus 2, if you cross multiply any of those, you'll find you do not get the minus 11x. They are all factors of the constant, but they don't work to solve for this particular equation. And again, you can check that out for yourself if you want to. Once we found the factors, what we have to do then is find the roots of the equation, and the roots are where the quadratic curve actually crosses the x-axis. To find the roots, all we do is take each of the factors in turn, equate it to 0, and solve the resulting equation. So taking the first factor of 3x plus 1, we simply equate it to 0 and then rearrange to find x. So in this case, we will take 1 from both sides and divide by 3, so x is minus a third. The second root in this case is to take the second factor of x minus 4, equate that to 0 and solve. In this case, it's simply x is equal to 4, adding 4 to both sides. So those are our solutions to the quadratic equation. Exercise 9a, part 2. In this particular question, we're given 4x squared plus 8x plus 3 is equal to 0. Again, it's of the form ax squared plus bx plus c is equal to 0. Using this method, on the left-hand column, we need factors of the ax squared term, which is the 4x squared term. Now, in this particular case, we could have 4x and 1x, as I'm showing here, as factors of 4x squared, and we could have 2x and 2x as factors of 4x squared. But I'm going to try the 4x and 1x first of all. In the right-hand column here, we need factors of the constant. In this case, the constant is 3, so I'm going to try 1 and 3. That's the only factors I can have if I'm using whole numbers. If I cross multiply, I get 4x multiplied by 3 gives me 12x, and 1x multiplied by 1 gives me plus 1x. Add them together, I get 13x. Is that the middle term? No, the middle term is plus 8x, so that's not correct. What I could do now is swap the 3 and the 1 around. I could put the 3 on the top line and the 1 on the bottom. And if I cross multiply again, I'll get 4x times 1, so that's plus 4x, and 1x times 3, so that's plus 3x. That gives me 7x. Is that the middle term? No, it's not. So obviously the 4x and the 1x are not the factors I need for the 4x squared term. Exercise 9a, part 2 continued. On the previous slide, we tried factors of the 4x squared being 4x and 1x, and that proved not to give us a solution. So now we're going to try factors of the 4x squared being 2x and 2x. Factors of the constant 3 are still 3 and 1. We cross multiply, we get 2x multiplied by 1, so that's 2x, and we get 2x multiplied by 3, and that's plus 6x. Adding them up, we get 8x. Is that the middle term? Yes, it is. So we've found our solution. So our factors, reading horizontally, would be 2x plus 3 and 2x plus 1. So if we expand those brackets, we would get back to the original equation, 4x squared plus 8x plus 3. Now to find the roots of the equation, we equate each of the factors to 0 and then solve the resulting equation. So in this case, taking the first factor, it's 2x plus 3 is equal to 0. So to solve for x, we take away 3 and divide by 2. So x is equal to minus 3 upon 2, or minus 1.5. The second root would be taking the second factor of 2x plus 1 and equating that to 0. And again, solving, we take 1 from both sides and divide by 2. So x is minus a half, or in decimal, minus 0.5. Exercise 9a, part 3. We're asked to solve the equation 4x squared plus 7x plus 2 is equal to 0 using the quadratic formula. The formula is given here for reference. X is equal to minus b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. In this particular question, the 4x squared plus 7x plus 2 equals to 0 is in the correct format to use the equation. In other words, it's in the ax squared plus bx plus c equals 0 format, so that's fine. Now we can read directly from the equation the constants a, b and c. So in this case, constant a is the plus 4, that's associated with the x squared term. Constant b is plus 7, that's associated with the x term. And constant c is plus 2. All we do now is put these values of a, b and c into the quadratic formula. Just be careful of the signs. In the equation, we start with
x equals to minus b. So that will be, in this case, minus the plus 7, so minus 7. Plus or minus the square root of b squared, so that's 7 squared, minus the 4 times the a, which in this case is 4, and the c, which is 2, all divided by 2 times the a, so that's 2 times 4. The rest of the process is now evaluation. So next step, minus 7 plus or minus, 7 squared is 49, take away 4 times 4 times 2 is 32, all square rooted, all divided by the 2 times 4 is 8. That's equal to minus 7 plus or minus the square root of 17, all divided by 8, and that's equal to minus 3 plus or minus 4.123, all divided by 8. 4.123 is the square root of 17 to 3 decimal places. Now don't forget, because we've got the plus or minus here, that means there are 2 solutions for x. So first solution, x is equal to minus 7 plus 4.123 divided by 8, and the second solution is minus 7 minus 4.123, all divided by 8. So in the arithmetic on that, x is equal to minus 2.877 divided by 8, or x is equal to minus 11.123 divided by 8. Just be careful of your directed numbers there when you're doing the arithmetic. Evaluating those expressions, we get x is equal to minus 0.3596 as a first solution for x, or x is equal to minus 1.39 as a second solution. Exercise 9a, part 4. We're asked to solve the quadratic equation 2t squared minus 5t is equal to 4 using the quadratic formula. The first thing to notice here is that the equation is in terms of t and not x, so it's a quadratic in t. That really doesn't matter from the point of view of using the formula. And also to notice that the equation is not given in the form of ax squared plus bx plus c equals 0, so we need to initially rearrange the equation into that format. So rearranging the equation to get the form of ax squared plus bx plus c equals 0, or in this case at squared plus bt plus c is equal to 0, we get 0 is equal to 2t squared minus 5t minus 4. In other words, what I've done here is taken 4 from both sides of the equation. Now that's the quadratic in the correct format, I can directly read my a, b and c constant. Now in this case, be very careful. The constant a is plus 2, that's associated with a t squared term. The constant b in this case is minus 5, it's a negative 5, that's associated with the t term. And also the constant c is negative 4. So very careful there. The sign in front of the number is with that number. So a in this case is positive 2, and b is negative 5, and c is negative 4. You must take the negatives with you, or else you'll get the wrong answer. All we do now is substitute those values into the formula. So in this case, t is equal to minus the b, which is minus 5, so be careful of double negatives there, plus or minus the square root of minus 5 squared. I don't really need the negative there, because when you square a negative number it's always positive, but I put it in for completeness. So minus 5 squared, then take away 4 times the a, which is 2, times the c, which is minus 4. Again, be careful of your directed numbers here. That's all divided by 2 times the a, that's 2 times 2 in this case. Exercise 9a part 4 continued. I just repeated the equation here from the previous slide. What we're going to do now is evaluate the equation. So t is equal to the plus 5 plus or minus the square root of minus 5 squared is 25, and we take away from that the 4 times 2 times a negative 4. Again, be careful of the signs, that's actually negative 32. And that's all divided by 4. And that's equal to 5 plus or minus the square root of 57. Don't forget the double negative, 25 minus and minus 32 is 25 plus 32. And that's all divided by the 4. And that's equal to 5 plus or minus 7.55 to 2 decimal places there, divided by 4. Now we got our 2 solutions. T is equal to 5 plus 7.55 divided by 4, or t is equal to 5 take away 7.55 all divided by 4. That gives us t is equal to 3.138, or t is equal to minus 0.6375. Here's a plot of the equation y is equal to 2t squared minus 5t minus 4. And we can see from the graph here that there's a root to the right of 3, so the above value of 3.138 seems reasonable.
and there's a root to the left of the minus 0.5, so the above value of minus 0.6375 also seems reasonable. Note the formula is the analytical method for solving quadratic equations, giving the exact values for the roots, whereas the graphical method is visual, showing the shape of the diagram, but it's more difficult to read the actual values of the roots. This is the bibliography used to help generate this presentation if you want further reading. I hope this presentation has been of interest to you, and thank you for viewing.